write another example of a tactic which illustrates a few things, such as running other tactics within a tactic and trying and failing. So our motivation here is when we want to prove something like this, that there exists n in natural numbers such that n star n is 64. In simple cases, we can see by inspection what works, and we can use the use tactic. If from MATLAB, if that's not available, some appropriate apply tactic. But in general, we may want to try many things, and we may not expect it to work straight away. We may want to simplify or reflexivity or something like that after the use. Yeah. So of course, just using after the use reflexivity here would be invalid because there are no goals, but we can always try reflexivity or simp or ASOP or linearith or some appropriate configuration. So let's write such a tactic. Okay, so I'm going to call it use still. So what is the syntax? I want to use still. Use still some number. So you can see an example commented out below. We use till 10 there, and then we use some tactic. Okay, it's more robust for the parser to say tactic sequence rather than tactic. Okay, well, the whole thing is a tactic. I should tell it that. Okay, and so again, we should not forget with main context do. Well, what do we do with the main context? First of all, let's get the number. Let n colon equals, we can just call it n.getNat. We don't need the syllabus later. So this gets a natural number from the syntax object. Okay, and we are going to go from n to 0 to n, 0 colon n. Well, of course, I want something j in 0 colon n do. And well, what do I do with j? I'm going to try something, and we'll successively correct our tactics. So let's try to evaluate a tactic. Okay, so what shall we evaluate? Having an eval, it's going to give bad errors, so let's just say catch. And for now, after catching, we'll just do nothing. Okay, so now we get better error messages. Eval tactic is, well, what tactic should I eval? Well, it takes a syntax and then it gives you a tactic, and we know from our macro examples how to construct syntax. Okay, so let's use this arrow notation and use the brackets for syntax. Tactic, use j. Okay, many things are wrong and many things are missing. We'll correct one by one. First of all, this is the wrong j. It just takes j as a variable here, and it actually wanted a natural number. I mean, it did. You can see this natural number is not used. Okay, so we'll create syntax for j. I'm just calling it j literal or something like that, jlit. So this is going to be syntax make lit. Oh, sorry, I want to be specifically make numlit. I would like to say j, but it wants a string, so that's not a big deal. You want a string, we'll give you a string. Easy enough to make a string. Okay, so we have this. And what about eval tactic? I want to use not j but $jlit, but it's not quite happy because it takes jlit is syntax.makeNumLit, which is not the same as a term, but we can coerce it to a term by saying, well, use a term based on this. Okay, so it knows that you can convert a numlet to a term, so it accepts this. Fine. Now what do we do after we evaluate the tactic? Well, we also wanted to evaluate the other tactic. Okay. And now if there are goals remaining, something is wrong. So suppose goals are remaining, give an error. Okay, there's something subtly wrong still which we won't fix in this video, but let's first say if the goals are, unless the goals are empty, do throw error. Goals remain. Okay, and then we can just return nothing if goals don't remain. Okay. Well, this is fine, but one of the problems that happens is that tactics when they run can mess up the state. In fact, these will mess up the info view. We are not going to clean that up. We just want things to run correctly. They are fine even if they're inside a try loop. So what we'll do is before we enter into the try, we will save the state. State we have saved is the tactic states plus some things at a lower level. We'll restore them. So there's the command restore state S. Okay. Extra safe, we'll also save our state before we enter the for loop. So we have a save state. And once all tactics have been tried, we'll restore the state, the original state. And finally, we will throw an error. All tactics failed. We can test our example, indeed. And indeed, we have our goals. We have no goals having. Okay, so let's just slightly soup this up. We have a try reflect that is a little bit of nuisance. Suppose after eval tactic we have no goals, then might as well return right then, right? So if slash L get goals dot is empty, then well, let's just return. Okay, so in that case, if we are checking in between after we just run the use, so if I say simp or reflect here, there should be no problem because it never tried it. Okay, so it tried a bunch of things. So that's the bit of the state in between that is leaking out, but finally the tactic is done. There is no problem. Okay. That linter is a bit silly, done never does anything. There is a subtle error here. The subtle error is that if we had more than one goal, you see, we are checking whether no goals are left. So then the check is wrong. So if we had more than one goal, for example, in this case, if I said cases 11 or something like that, okay, then it says all tactics failed. They actually succeeded in our goal, they just did not close all goals. So we need a refined way. We will eventually see that when we use not eval tactic but run tactic at an elab level and then check whether a specific goal has been saved or not. So this is just a warning. Things are quite subtle, so this thing we did not do, but we illustrated a few things here, such as running tactics with other tactics. As to go back to one of our early examples where we used first. First is implemented in this way. You have a bunch of tactics different from each other.